get started. Pattern recognition. Have this guy, right? Oh yeah? What did I say this one was? So first thing is we were sorting, so we have nums, which is the number of elements that we have, right? And when we say num.sort, what we're trying to do is we're taking every element and we're sorting each element. So that is what? N, which represents each element, right? The complexity of sorting in general. What sorting is what? Logarithmic. For most out of the box sorting functions, built-in sorting functions, it's usually log. So that's what's n, log n, that's for each element. Well, first it sorts everything, right? So wait, hold on. We simply sort everything first. We have order n, log n. So for each element, it has to sort it. It has to go through the sorting algorithm, which is modified insertion sort. From what it was saying, a modified insertion sort and a merge sort. We know merge sort halves things. So that's n log n, and then the one below it is just order n, but we're taking the highest order of complexity, which was n log n. Okay, this was my statement here. Order n log n, for each element it has to be sorted. Then we have a for loop that's order n. We take the higher complexity with order n log n here. Okay. This makes more sense. Much better. Alright, let's continue with this pattern recognition. We're going to rotate between these guys. Shoot. I'm running out of time to try and lock in better. Alright, what's the complexity for this number? So that's what I had. So we got that right. Snippet. What is this? Pair comparisons. So tell me it's complexity. Let's see if I can do this quadrat. Why is it giving me a hint? It shouldn't give me a hint. problem. Heap size K utility, and yeah, this one is confusing. What does that mean? Makes it quite confusing. And look, and I recognize these ones. All up to here. This bit mask one, what is that even? What the heck is a bit mask? Use dynamic to improve that portion of things. What does this do? What does heap push? Heap PQ, heap push. Attributed the trickier NLK versus K-log and present extra. Order n log K, loop over and maintain a heap size K, import heap PQ. Okay, my first thing here, right, if we're looking at this algorithm and it's saying for each element, right, add the num and then passing this empty heap, what does heap push do? I need to reflect, review how a heap works. So, let's see. What? Does exact. How does it transfer? Because if heap just need to understand Alright, let's try and understand what this is, man. Or I say us. Let me try and understand what this is. Kind of data structure, big makes big or click. Let's break down what step by step so you can see how to maintain. Hit PQ, push. Oh, did I run out of time? I think I ran out of time. We need to switch gears instead. Like, why are there 5 people suddenly? Let's insert item into the heap, which is just Python this. It maintains the heap property. Smallest item is always at the root. It does this using a process called heapify up, which adjusts the list iteration. The list after insertion. Think of it like inserting a new player into a correct place to maintain. Okay. Insert at the end 5. So where did 2 come from? Oh, step 2 insert 2. Okay, I see. Why did it change the way it prints? Anyway, so it's 2 is in front. Insert 8. It's 2, 5, 8. And at the end, insert 1, 2, 5, 8, 1. Compare with parents 5. Swap now 2, 1. Now 1, 2, 8, 5. Five to 8 1 5 5 to 8 1 5 to 8 1 5 2 8 1. I see, so 1 is greater, comes here. If we skip backwards, can we skip forward? Can we move forward? Oh, I see. And then 8 is going to be to the right of 2. What is greater than, and then 1 is going to say, is 1 less than 2? Yes. Is 1 less than 5? Yes. We've reached the end, and then it swaps in place 1 to 5 and asks, this is my parents, that's okay. But in binary heap, the height is block K. You might have to swap up to the root, the worst case. Inserting one item costs order block K. So it just does that sorting. remove the minimum and then reheapify. Interesting. It's a self-sorting heap. Heap 0. Pick the minimum, which is always going to be order 1. Order log k, where k represents what here? Log k here. Ten, 4, 15, 2. So what's that going to look like? What's to visualize this? Oh my gosh. Turn is inserted. Let me insert 4. And then it's going to update, right? So 4/10. So what's going to happen? The next thing we insert 15. We're going to have 15 here. And then we're going to swap 15 and 10, which will be 4, 10, then 15, right? Then we're going to insert 2 to fall in line here, right? Pops, 2 fall in line here, and since it's reached the end and there's nothing else, it's going to ask the question, is it older than its parent, right? Like, is it older than the correcting node next to it? And the answer is yes, it is. So it's going to swap to 4, this will still be 10, this will be 15. I wonder where something like 9 would go in this case. If we said 9, we'll come in here and say 2 is greater than, is 10, is it greater than 10? No, it's not. Then it might probably come here, 9. Okay, interesting. It's good refresh. Heap PQ, heap pop, heap. What does that even mean? Oh, we've added onto the heap. So we'll pop 2 out. But I mean, at the end of the day, before that happens, right? Just to check my understanding. This will be sorted from left to right, right? So the top is going to be child, so we'll have 2. We'll have 2, 4, 10, 15. 2, 4, 10, 15. At the end of it, 2, 4. Now 2, compare 2, and swap. I don't know about the end though. They have to do one more. Because yeah, we see 10 and 15 here. Was it really 15, 10? No need to swap 15 and not greater than 4. Ah, so I did an extra step. Interesting. So it's at the end and bubbles up log k. Removes roots, removes last item to root. What does that mean? Removes last item to root. Quiz snippets. I still have questions, bro. Alright, what does K represent in the heap problems? N is equal to total number of elements in your input, usually a list. Think, how many things am I scanning through? Yep. K, how many results you're trying to keep or extract? Top K. How many things do I want to track? Ah, okay. So it's what we tend to track. So in that case, can we say, let me ascertain something here. The freedom to be curious and foolish at the same time, or less ignorant. With this statement, does this mean K is a subset of N, where N, K is a subset of the initial elements? Then why didn't they just say that, man? See, sometimes we have a tendency to be ignorant and doubt the way we think. But if I didn't ask that question, it wouldn't have made sense. I'm like, when? That's way simpler. Why don't you just say K is a subset of N? Like, I literally had to rethink and respond for it to say that. Like, that's way more simpler. I could argue with ChatGPT and be like, oh, why didn't you say that? Well, I'm slightly better than that. At least I'd like to think so. No, why is it? Hold on. Huh? I don't recognize this. Oh, I went to a different tab. I see. It's like, what window is this? Entire input, the full list, stream, array, or iterable. You're pressing all of these items. K subsets, you're extracting or tracking. Top K, smallest K, most frequent K, T. We don't care about the N minus K. What did it call it? 1007, you want to keep track of the top 10 scores and students. Keep best scores, order log K. Heap stores only k items. But I don't think so though. For every element, right? Heap push, we push in the heap and that number, and we active the length is greater than k. Oh, it's inside a for loop. So literally n log k for each element. We want to get k. So we're not going through the full thing. I see. So we scan through all k values. Oh, I see. I mean, technically it's better to break then. So that's order n. If length is heap is greater than k, heap.pop. We remove the heap.pop here. Interesting. Oh, the pop is the representation maybe. I'll probably print that out. So this makes a little bit more sense now. Okay, let me try and solve 3D more. Then let's go. Let's answer time. Want a comparison version using k log n. Excellent. Using k log n. Heap is an n log k problem, right? It's n log k. It should be, right? Heap push time complexity is log k. It says. On its own, yes, it's log k. Just on its own, yep. Iterations through it, then that becomes the n log k, because for each element we're going through, we only want k number of items. What's interesting about this is k, I mean, we're using a heap, right? So by design, k would not exceed the number of elements that are inside here. Was made to assess my for num and nums heap this is order, and so for each element what it's doing is pushing onto the heap that number, okay, until it reaches what, k. Length is greater than k. What if it's not? Like, what if we go past that point and everything just goes through, right? I guess we're doing this within constraints, assuming k is less than, with our assumption that k is going to be a subset of nums, like the total number of elements inside nums, so it's an iterable, then yes, this is order n log k. We're using a heap, so right? The length of the heap is greater than k. Heap, pop. pop that amount, and then the next thing adds up. Check if it's greater than k. That's going to take. Oh yeah, because after each time we pop, the heap would resort and bubble up. Space complexity is what? Not really storing anything, but passing each number in. I mean, I guess within memory, it might have to shuffle in place, but yeah. Where log k shows up. That'll be the heap. Where log k shows up will be right here, right? He pushes, he pops on a heap of size of the log. Does this in half. It grows only up to size k, but tracking the top k items. All the growing structures, so space is order k. Extra memory algorithm uses relative to the input size. In regard to the input size, which includes all of these, not counting the input itself, not just whether you wrote my list, but whether something in memory grows as the input grows. Oh, something in memory grows as the input grows. It's not about extra spacing that we're using. List sets dictionary heaps. Extra memory. So in this case, after we push onto the heap and it does its balancing and we reach heap, length of heap that's greater than k, the heap pop, I guess memory will be adjusted several number of times, right? Because what did they say with heap? There was a diagram earlier. Where's this diagram? This diagram was saying something about if you insert, it's like insert takes this amount of time, remove takes this amount of, okay, yeah, there's it. Insert and restore. And restore, is that? Why? What does that even mean? But when we insert, we always restore the main heap order, which is at the top of the tree. That's order log k, because it's k number of times. Well, not necessarily k number of times. because in our example we didn't need to push like when I think about k number of times, I'm looking at it in regard to the conditional statements, the if conditional statement. So right now it's like, because of that I have bias to see, I can see the log k here when we pop things from the loop. But order log k, oh, because it will take half the time because it's sorting in place. Whether we insert or we remove something, we don't need to go through every single element in the list. It's self-sorting, it's self-balancing to put the minimum at the top, so it takes half that number of time because it's efficient enough, it's balanced to allow that to happen, to allow us to not go through every single element in the list. Okay, it's making sense now. It's making sense now. $58, oh my goodness, we did not do any AI coding, man. I need to put a self note here. I don't even really do a good job taking track of these notes I'm taking as well. Sound ridiculous, but I can't wait to wake up to just pick up studying again. Big O complexity recognition. Order log k or order n log k, usually associated with heaps. It's log cause when we insert or remove, we are sorting in place in the tree. Takes half the number of times. K is a subset of n. Okay, that's some good notes. All right, let's continue. Even though you see just heap ones, this heap is growing to size k. every heap push adds to it, even if length of the heap is greater than k. Ensure it never holds more than k items. Okay, because we pop that amount, so it halves it. It limits it to k. I see. That empty grows up to size k because heap can hold k items. Okay, even if you create another variable like extra space, the heap is that growing structure. The heap is the structure that is growing. Okay. From this observation, is it true that heap order log k or order and log k? Minimum heap for top k largest, heap smallest on top. Max heap for top k smallest, heap largest on top. The heap grows to size n, not capped. Then you're in order n log n memory. Is there any other n? Tree sets in Java, B trees. Sorted list or tree sets balanced log k and log k. I see. So when dealing tree What does a dynamic order structure even mean, bro? Limits the structure to size K, I understand. Processes n times, yeah. But what does maintains a dynamic? Supposed to be using words, and I'm like, huh? A dynamic order structure is a data structure that automatically keeps elements in a sorted order. So you insert or remove them without needing to explicitly sort every time. You add things in any order with the structure of the orders itself as needed. Heap. Only root is known. Balanced full order, sorted list. Same thing. Number of inputs. Okay, smaller subset. Quick lookups, one pass solution, sorting efficient, divide and conquer, pairwise comparison problems, like brute force, matrix traversal, and then you have order, interesting, order log n. It's like, why don't you quiz me on that 2080 instead? Yup. Me. On track and quiz. K log n means you're doing K operations n times. Each operation takes log n time. We have our sorted data, we have K volumes, we have our results. For every item in the values list, whatever that is, index results at append. So we want to say bisect. The F is bisect, bro. Sorting items into a sequence if it's ordered. We use binary search to insert the right items, okay? So if you have your sorted data and this is the target node you want, right? Assumption sorter. You're performing these k or this number of operations. K log n. For target and k values, IDX equals to bisect or bisect left sort data target. So we're taking the sorted data. The target is for where we want to insert that in the binary tree. You know, it's a binary tree, so it has dynamic, whatever it was called, sorting, a dynamic structure, dynamically ordered structure. So that's going to be the log. So it's well, since we're looping through each thing, doesn't that mean it's like n log k as well? We perform k operations, which is this bisect. N number of times on this dynamic structure. Bisect left. K value has k elements. Oh. We're not going through each sorted data. It's the number of values you want to insert onto that data. Or can we presume that it's going to be a subset? And why should that be? Is order k log n or order n log k, and why? We are going set we have a binary search. We are doing k times this thing is interesting, bro. Why does this say lock in? Like, where did this terminology come from? Loop over input and use heap of size k, and that's n log k. Loop over k values, binary search n. On every now and then. Benzeri. Say binary. I mean, the hard part is, as mentioned to Teresa, Terraform. Okay, let's get to it then. What is the time and space capacity? Num threshold, total 0 for now. Total plus num is equals to num. That's just an operation. Probably n number of times, right? Total is greater than threshold. Break. If total is greater than the threshold, break. Well, threshold is what they put in here, right? Well, worst case, okay, let's take this up from the worst case scenario. Worst case, this could be still order n, but there's a possibility it would never be greater than the threshold. Complexity, order n, worst case. Wait, if the total, that means threshold is less, right? The threshold is never met. But what does that mean by computation here? The total is bigger than the threshold. So that's, the threshold is basically always less than or equals to. That'll be the way to see this. It would value of threshold is it order 1 or order n? Because it's for each element, right? We're updating that in memory. Adding to the total. This means order 1 Oh my gosh, bro. In the worst case, you go through every element and hitting the threshold and makes it linear. Yeah, you're correct. This is used in place for not soaring, growing. Dictionary. So space, because only one variable is used regardless of the input size. Okay. As the amount of memory grows with input size, the value of it increases, but not the size. Only counts such accumulators. Build a new list of dictionary order n. More recursive without memorization. Because of the top memorization, that's the recursion of multi-dim list. Pattern early exit from a linear scan. Accumulator reused order 1 space. Okay. So if we have an iterable, that's order n. Period. That's it. we're using an iterable for storage, then it's going to be order n. Now, if it's recursive, what? Oh, okay. And that's n squared. So n is 4, so that's more recursive. To the constant. Oh, multi-dimensional. Okay. For whatever in range n. What do you want to do? I want to create a list from 0 at 0. Oh my goodness, bro. A list of a list? In this case, it's all zeros. For row in grid. For value in row. Yeah, that one is identifiable. 1-dimensional, 2-dimensional, 3-dimensional. Let's continue 80, 20. 5 more questions for now. Those 2 loops, right? Yep. Order n squared equals to order 1. I don't see any other memory being used. But that's a repeated question though. You have a norm, you have a target. If num is equals to target, that's if it's equals to target. Oh, damn. Or return the sum. For each element, it has to sort it, right? Yeah, that should be order n log n. But for each element, that needs to be sorted. Well, just order log n, right? Because now each element has to. Are we sorting each element? Because that will make it order n, then log n. But if it's just going through to sort the thing, I'll take my chances, bro. Log n space sum the numbers. This is still order 1, man. I don't see no iterable here. Oh no, wait. In memory, it has to keep track of all these things to sort it, right? So that should be order n, worst case. But I'm really tricky about this. Like, it almost seems like it's order n log n, but the n would be for iterating through to sort every item, right? First. Otherwise, it would be logarithmic. Shit, bro. Tell me. It's n log n? Why the f is it n log n? But for each element, we have to go through and sort. Sorting can never trust. I have to go through every item on the list. Right. Well, n is greater than 0 and is equals to n1/2. Wait. It's half in it, literally. It's like you have to get both right? complexity of this, add card numbers, results for, so that reminds me of a loop. I'm putting an n here just in front, just in case, wait. For num and nums, if num mod 2 is equals to 0, result append. We're going to append that inside there. I would suggest space complexity of order n as well. Well, this is looking like order n to me, honestly. It's looking like order n to me. And then space is equals to order n as well. But there's no possibility that number is going to be that, right? But worst case, we take things from the worst case. It says we're going to append. So it's order n and n. Is there any recursive calls? No, I don't see it. Iterative calls? No. Alright, chat. We're gonna switch gears now for this app and why it's not working. I can't tell. Agent ran into an error. What's going on? My pause rep previously is expecting a different configuration. It's likely that rep is routing system isn't properly configured to forward traffic to our Node.js server. It's even running right now. It's console space. It's my chat. It's my chat here for notes. Let me try and work an approach. Let me create a proper workflow and understand the issue. The server is running correctly. We can see Rafa's previous system has specific requirements. Let me try and direct approach by testing the external URL and providing with working solution. Issues clear now. Server is working. This has just been refreshing the same thing, right? So Replit has a tendency. I need to note this down. Replit has tendency to spiral / loop on past conclusions. Iterate on its hypotheses, even though said even though it has reflected on said all before. Shows less of progressive correction. Example. Keep saying Oh, really? On a new browser tab? Now, let me see if this is true then. Let's see if this is true then. The configuration mismatch with Replit internal preview system. What does that even mean? So that upgrade required message in Replit preview panel is a configuration mismatch with Replit internal. So I'm curious how that was fixed. How was that fixed? And what is this agent error I was having? No workflow seems to run at the moment. Please run the workflow. Checkpoint, improve application startup and error handling for a smoother launch. Yeah, let's see then. It's just that the issue is clear now several times. It said this issue is clear now. It's the same problem. Alright, let me save this as well too. From observations. Shouldn't I have observations somewhere? Okay, so we have that down. Oh, that's time already. Damn. I need to be better disciplined and just go to bed. 151. So if I did 20, this should be 21, 22. This should be 22. Easily 22. The app is running, but the preview isn't ready. Oh my, the preview isn't ready. This is some mad things, bro. It's taking a lifetime to start up. So enter this. Enter this on my Chrome browser. And preview is ready. Cost 3,000. It's saying it's running on. What is this? Okay, let's see. Let's see. Upgrade required, bro. You know what? Oh. No way. Why didn't you just say that then? But is that true? Very suspicious. Very suspicious to me. Oh, thanks, Law. Thank you. On the T... public. If I started in free tier, you still see the pen. Is this to plan limitations? What's their different pricing though? Let me research something proper. Hold on. I might start this from scratch, I won't lie. I might start this from scratch, but hold on. $1.64 use, additional usage, nothing. Yeah, I'm good then. $1 use, just $1. Deployment, nothing. Quota usage, nothing. Yeah, so this should not be a thing. Your plan, Replit Core. I'm literally on Replit Core. Alright, so now with all this information, let's go back to our application and figure this out. How many hours are we in? 1 minute before 2 hours. Then we go to sleep. We've got to go to bed and pick this up again tomorrow. We'll see the upgrade required on preview pane. Is this due to subscription plan limitations? I started initially on the free tier, then upgraded to replicable. Or is this still an issue with the this app's configuration? My next alternative will be to start again on a new chat. Be such a waste of time. So two options. So let's have two alternatives here, right? One, this is fixed shortly by bracket you to commit what we have onto GitHub. Guide on how to test. I don't even want to follow two because it's more expensive. And 3, start a chat. Share to me all the promptings. Man, yeah, I ain't doing nothing, man. This thing can barely do a simple application, bro. So all this AI hype, as someone who has used AI, a more advanced version of this one, and then this one that's supposed to be hands-free and it's still failing. Yeah, it's got a ways to go, man. It's just not cognitively smart enough. I'm also taking a lot of journaling notes here on its limitations, so that I can self-reflect. Let me implement option 2. I said, hey, we got a problem here. We've been trying to fix this problem for a minute. So here's some proposals, right? 1, you fix it shortly. 2, just save what you have and I'll figure out the rest on my own free time. And then 3, I start all over. It's like, oh man, I don't want you to start all over. Let's commit what you have. I'm definitely going to start all over. This is research engineering with AI. So we're finna figure this out. The app works perfectly. What do you mean it works perfectly? Like, you have to know what you're doing before you give it this thing. Now the application is running on port 3000, but maybe it's been served on port 3001. Like the UI server is different from the application server itself. Usually that's how it goes. But let me see what it's saying here. Perfect ever. Oh wait, what did it do this onto? Execute. Let me create the Git setup and provide you with everything you need. Complete GitHub ready project. Wait, what? Hold on, let me ls minus lrt. So this is workspace, but let me say git status on branch, nothing to commit, working tree clean. How do we commit this to a GitHub account? That's the main thing. Your GitHub repo URL. Create a new repo on GitHub. Okay. So at least it's given instructions on how to save this. So yeah, we're honestly going to save this and pick up from there. It's 2 hours in. It's time to call it and go to bed, man. Yeah, that's it.